Question 1, Part B. Find the acute angle between the lines 2x plus y equals 4 and x minus y equals 2 to the nearest degree. We can use vector techniques to find the acute angle between the lines 2x plus y equals 4 and x minus y equals 2. What's important is to know the gradient of both of those lines. And in order to do that, we need to rearrange both of these equations into gradient intercept form. So 2x plus y equals 4 becomes y equals negative 2x plus 4. And this is aligned with gradient negative 2. And x minus y equals 2 becomes y equals x minus 2. And this is aligned with gradient 1. Now let vector u equal 1, negative 2. So a horizontal component of 1 and a vertical component of negative 2. And this corresponds to a line with gradient negative 2. Notice that the y-intercepts don't actually matter in this case. And vector v is defined as 1, 1. So a horizontal component of 1 and a vertical component of 1. Then using the dot product formula, the dot product of vectors u and v is equal to the magnitude of vector u times the magnitude of vector v times cos theta, which is the angle between those two lines. So the dot product, so that's u dot v, is 1 times 1 plus negative 2 times 1 is equal to the square root of 1 squared plus negative 2 in brackets squared times the square root of 1 squared plus 1 squared times cos theta. So this corresponds to the magnitude of vector u, and this corresponds to the magnitude of vector v using Pythagoras theorem. Now the left hand side evaluates to negative 1. And the right hand side simplifies to root 5 times root 2 times cos theta. Now root 5 times root 2 is root 10. We can rearrange this equation easily enough to make theta the subject. And we get theta is equal to inverse cos of negative 1 divided by the square root of 10. And this evaluates to 108.43 degrees, correct to 2 decimal places. Now this is an obtuse angle, but the question is asking for the acute angle. So to find the acute angle, we subtract from 180 degrees this value here. So 180 degrees minus 108.43 degrees, and we get 71.57 degrees, which is equal to 72 degrees, correct to the nearest degree. Using trigonometric techniques to find the angle between the lines 2x plus y equals negative 4 and x minus y equals negative 2. Firstly, we consider the gradient of the line 2x plus y equals negative 4, and the gradient's negative 2. Hence, tan alpha equals negative 2, where alpha is the angle of inclination of the line 2x plus y equals negative 4. Now consider the gradient of the line x minus y equals 2, and the gradient is 1. Hence, tan beta equals 1, where beta is the angle of inclination of the line x minus y equals 2. Now let theta be the angle between the lines. That is, theta equals alpha minus beta. Now we take the tan of both sides of that equation. We get tan theta equals tan alpha minus beta. So we have the tangent of a compound angle here, so the difference of two angles. And expanding tan alpha minus beta, so expanding the right hand side, we get tan theta equals tan alpha minus tan beta over 1 plus tan alpha times tan beta. So if we go back to here, we have a definition for tan alpha, and that's negative 2. And we have a definition for tan beta, and tan beta is positive 1. So substituting those values for tan alpha and tan beta in the right hand side of this equation, we get tan theta equals negative 2 minus 1 over 1 plus negative 2 times 1. And this fraction evaluates to 3. So the equation simplifies to tan theta equals 3. Taking the inverse tan of both sides of the equation to isolate theta, we get theta equals inverse tan of 3, which is equal to 71.565 and so on degrees, which rounds to 72 degrees, correct to the nearest degree.